Did you know that the physics governing the motion of linked bodies under load can help us to understand the complex movement underlying some everyday challenges, technology, and sometimes tragedies? For example, we can learn how the shape of a car front could influence the outcome of a collision with a pedestrian or a cyclist. Or, in the case of a robot, we might want to understand how to program its movements to produce a particular outcome. Or, in the case of a collision sport, we might want to understand how the tackle height could influence head kinematics in a game like rugby. So all of these topics are linked together by Newtonian mechanics. And in the case of injury analysis, we can link this with injury biomechanics, and we can reconstruct an accident, make a prediction about what kind of injuries we might expect. And we can code all of this on a computer to run what-if scenarios to tell us how things might change if something had changed about the input to the problem. And so my name is Ciaran Simms. I'm on the engineering faculty here at Trinity College in Dublin. I run the Multi-Body Dynamics module 4B17. It's a fourth-year course aimed at engineers. I conceived this program in 2012 to try to marry my teaching interests in mechanics with my research interests in injury biomechanics. I've been very fortunate to work on a range of injury-related topics, and the theory of this module is exactly what I need to work on a large part of my research. The module is aimed at engineering students in their fourth year of studies. It assumes that you have a foundation in linear algebra, in mechanics, in computer coding, and it allows us to then address all of the topics I've talked about above. So what we're doing in this module is we start with a self-guided assignment where students work on something simple like a leg, kicking a ball, and in doing so you learn how to understand basic concepts like three-dimensional rotations, like moments of inertia, like how to model contact forces, how to deal with linked bodies working together. And from that we introduce our face-to-face lectures, and in these lectures we tackle the admittedly sometimes tricky mathematics, which addresses three-dimensional rotations. We derive the equations of motion for linked bodies in rotation and in translation. And we introduce all of these topics through the application to a group assignment where students pick a topic that they want to analyze through multi-body dynamics principles. It could be a climber falling, it could be a vehicle collision, a sporting collision, a robot. It is up to the students by and large to make that choice. And we also learn cases where multi-body dynamics is not appropriate. And we then move on to the principle of virtual power, which is a mathematical technique which allows us to very efficiently code the equations of motion on a computer for them to be solved by numerical integration to allow us to predict, based on knowing what happened at the start of the simulation. The equations will then tell us how to move forward in time and understand movements of the head or the arms or whatever we're trying to study. So the mathematics can be tricky at the start, but there's a great payback, because when we have this mathematics and theory under our belts, we have the tools to study the world around us and how we physically interact with it in ways that we can't do without this material. And so if you're interested in this subject, in multi-body dynamics, or in my module 4B17 at Trinity College Dublin, please get in touch with me. I'm Professor Ciaran Simms. I'm at csimms@tcd.ie. I look forward to hearing from you.